We're going to look at concave mirrors, and we're going to look at an instance when the image of the concave mirror is directly at the center of the spherical mirror. So here's our spherical mirror, and we're on a Cartesian plane, and imagine this is the center of the circle. And there's a couple of formulas, and just to draw a reference to the first formula, that 2f is equal to c, that the focus pole, or the focal point, is halfway from the center to the outside of the mirror. Now, with the whole circle, it's hard to imagine this mirror, so we'll kind of get rid of the entire circle, and we'll just focus on the mirror part here. Okay, so here's our mirror. Here's the center, here's our focal point. And we have our formulas. Our first formula here is 1 over the focal point is equal to 1 over the distance of the object plus 1 over the distance of the image. And the magnification is equal to the height of the image over the height of the object, which is equal to the negative distance of the image over the distance of the object. If you don't know what each of those letters stand for, you can pause the video here and quickly just look it over so you have a reference, okay? But here's our thing. And instead of doing the regular, we have the object, we have the distance, we'll do the opposite. We'll say we have the mirror image, okay? So here will be our mirror image, okay? Our mirror image we'll draw in, I guess we'll do it in blue. Okay, so here's our mirror image. It's at a distance from the center of the mirror here. It's a distance of 6, okay? So our distance of the image, okay, so this is the mirror image here, is equal to 6 units. Could be centimeters, meter, whatever you want. And we'll say that the height of the image is -3. So if you notice, because it's below the x-axis, and again, because it's an image, the height of the image is equal to -3 units. Okay? And that's going to be important for finding the true height of it. Now, we know that's technically where the center is. So because that's the center, using the very first formula, and we can see it from here, 2f is equal to 6. 6 is where the center is. That means f is equal to 3. So the focal point is at 3. So our second formula here, the number 2 formula, is 1 over the focal point, which is 3, is equal to 1 over the distance of the object. That's our unknown. We're pretending that we don't know where the original object is. We can only see the reflected image. Okay, plus 1 over the distance of the image, which is 6. Okay, so now we just got to isolate for the distance of our object. So we're going to bring 1 over 6 to the other side. So we have 1 over 3, subtract 1 over 6, is equal to 1 over the distance, lagging a little, of the object. Now, in order to subtract these fractions, we need a common denominator. So we get 2 over 6. We multiply the top and the bottom of this fraction by 2. Okay, subtract 1 over 6 is equal to 1 over the distance of the object. And 2 over 6 minus 1 over 6 is just going to be 1 over 6 is equal to 1 over the distance of the object. And we know that if we quickly cross multiply here, okay, so if you quickly cross multiply, you're going to get that the distance of the object is equal to the value of 6. With that being said, we have the distance of our object. That works out really nice. So we have the distance of our object. So that adds a little more. We also have our third formula. Okay, our third formula stating that the magnification was equal to the height of the image over the height of the object, which is equal to negative the distance of the image over the distance of the object. So the distance of the object we just discovered to be 6, so we know that. We can replace this value with 6. And the distance of the image, which is the very first thing we had started with, scroll on up here, is also 6. Okay, so we have that at also a value of 6. Now, because there's a negative in front of it, we're going to replace just this part with 6, so that will become a -6. So it'll look like this, -6 divided by 6, which is essentially equal to -1. Magnification, that really means that the magnification is also equal to 1, so we got that part down. And the height of the image, remember the height of the image we said, and go back up again, was -3 here, okay, because it was below the x-axis. So the height of our image is -3, so we put -3. and the height of the object, the original object, is unknown. So again, we can do some, we simplify the negative 1, or sorry, negative 6 divides 6 to get negative 1. So we get negative 3 over height of the object, okay? Now we want to isolate for the height of the object. So we bring our height of the object over here. So we get negative 3 is equal to negative 1 times the height of the original object. And sorry for the lagging here. And the height of the object, to isolate that, we divide both sides by negative 1, or you bring over this negative 1. And you get the original height of the object at the value of 3. Okay? Negative 3 divided 1 is, divide negative 1 is 3. So let's draw our original object. And this is the case for whenever our image is actually directly at where the center is. Sorry, it's going up and down a lot. Okay, it said that the distance of the image was 6 units and that it was positive 3. So this is our original image. And according to our rules here for our concave mirror, when we should draw a line parallel to the image, and then when it bounces off the mirror, it goes through the focal point. Okay, so we'll try to draw our straight line there. And then our next one goes through the focal point, about there, okay, and then it reflects parallel to where it was. So, and you can see, now my drawing is imperfect, but where they cross each other is essentially where our reflected image would be. And a reflected image is the exact same distance, okay, and it's actually negative 3 in terms of the height, where the original one was at positive 3, and that's the case. Whenever we're directly at the center, the image will be directly at the center, just inverted in height. It won't be the positive value, but it would be the negative value.